Oh, okay.
Okay, in case there is no question, let me go back to the start of the course where I made a map of whole course, and from there I will tell you what is going to happen now. If you remember at the start of the course, this was what we said. We said the subject statistics is a science of making decisions under uncertainty based on the data. And we said that statistics is it has two branches. One of them is called descriptive statistics, where we only describe the data. And we said this we will cover in the lab. And your book will cover this in chapter 6. And the second branch of statistics is called inferential statistics, where we draw conclusions about population based on sample. We haven't done that yet. We haven't done that yet. So we draw conclusion about population parameters like mu, like sigma, based on the sample statistics like X bar and standard sample, standard deviation, and so on. Now, to bridge the gap between descriptive statistics and inferential statistics, we have probability theory. So we are done with that bridging between the descriptive and inferential statistics. Now we have enough information about probability theory. We know what is basic probability. What we know is the discrete distributions, the continuous distributions, and the sampling distributions. Now we are back in the position of starting with the inferential statistics part. The inferential statistics part will be a part where we will draw conclusions about the population parameters like mu. Mu is the mean of a population. So we will draw conclusions about population parameters based on the sample estimates. So if mu is the population parameter, who can tell me what is the thing from sample that estimates mu? How do you estimate mu?
Uh, by the whole number of the sample divided by its number.
Which is called
The average.
average, sample mean. So you estimate the population mean with sample mean. Now the estimation is done, that is descriptive part. Now based on this sample mean, you will say something about the population mean, and that is called inferential statistics. So we start with the most popular population parameter, which is mu, the population mean. So let us have a population. On random variable, let us say X. And in this population, you have, let us say, finite or maybe infinite number of values of X. Capital N may be a finite number or maybe an infinite number. Now this population is explained by a probability distribution model, f of x. Maybe normal, maybe gamma, maybe Weibull, maybe whatever. It is explained by a probability distribution, maybe discrete, maybe continuous. This probability distribution, it has a mean, it has a variance, which are unknown. These population parameters are usually unknown. To estimate these probability, the population parameters, what do? We pick sample from this this population. We take a sample from this population. That sample is x1, x2, all the way up to x small small n. The size of the sample is n. What do we do from this sample? We calculate x bar from this sample. That is the sum of observations divided by the number of observations. And what do we say? We say this x bar is a point estimate of this mu. Up until this point, this has been the whole story. If x bar is kind of, let us say 80, you will say your population mean will be around 80. Now, when I say around 80, how much around 80? How far it can be from 80? Can it be 80.1? Can it be 80.2? Can it be 81? Can it be 79.9? How far from 80?
That what you said is right. Not very far.
It should be close, yes. And how close it should be, it depends upon your sample size. If your sample size is fairly large, it should be fairly close. But the question is, how close? The answer lies in the sampling distribution of x bar. Chapter 7. The answer lies in the sampling distribution of x bar. How is x bar distributed? The distribution of x bar is normal with mean what? Either exactly or approximately. It follows normal distribution. The center is mu and the variance is sigma square over n. That means the standard deviation is sigma over square root of n. So according to the empirical rule, almost 99% of the variation in a variable is captured within plus minus 3 standard deviations. So if your sigma over square root of n is, let us say 1, let us say if your sigma over square root of n is 1, you should be 99% confident that your mu value is between 77 and 83. Plus minus 3 standard deviation, standard error or standard deviation, I would say. So if your point estimate comes out to be here, let us say x bar is 80. This is minus infinity. This is plus infinity. Now mu can be anywhere from minus infinity to plus infinity. We don't know where is mu, but we can say we are, let us say 95% or 99%. If you say 95%, that will be plus minus 2 standard deviations. So let us say your sigma over square root of n is, let us say 1. Then you can say that your mu, we are 95% confident that your mu is between 78 and 82. Now, when you say we are 95% confident that your mu is between 78 and 82, what is this? I just said something. We are 95% confident that the population mean which is unknown obviously, is between 78 and 82. This statement is about what? This statement is about mu. I'm giving a statement about mu. Based on what? Based on sample information. Muhammad Faris.
Yes, doctor, about 2 mu and minus 2 mu. Right?
Yeah, exactly. So this is basically x bar plus 2 times. This is basically x bar plus 2 times sigma over root of n, and this is x bar minus 2 times sigma over root of n. This is plus minus 2 times standard deviation. Nawaf Ali.
Doctor, what is the difference between the word confident and probability?
I will talk about this one. I will talk about this one. By the end of the class, if I don't talk about this one, let me know.
Okay.
So what I'm saying is that we are 95% confident that the population mean is between 78 and 82. This is a statement about what? This is a statement about mu. I'm giving a statement about mu, but I don't know mu. I have no information about mu. I have information about x bar. So what is this? I'm doing this, what I wrote in the red color. I'm saying something about the population parameter based on sample information. So I'm doing inferential statistic. This is called inferential statistic. I'm drawing inference about population parameter mu based on the sample information. Now we come theoretically towards how do we derive. The derivation is not with you. It is simple derivation, but this is interesting and it will make your concepts clear. So I'll quickly go through the derivation of this confidence interval for population mean. So you can see the confidence interval. This is kind of called confidence interval for mean, that we are a specific % confident that mu will be between this and this. You can see it is coming from the sampling distribution of x bar. It is like x bar plus or minus something times sigma over square root of n. And the sampling distribution of x bar is what? It comes from this z. The sampling distribution of x bar is where z follows a normal distribution with mean 0 and variance 1. That is the sampling distribution of x bar. So if you are interested in mu here, you solve this equation for mu and see what happens. So solve this equation for mu and you get what? X bar minus mu, that is sigma over root of n, z times sigma over root of n. Right? And then you take mu to the other side and you'll get mu equals what? X bar minus z times sigma over root of n. Now this z will be sometimes positive and sometimes negative. If you are above 0, this will be a positive value. If you're below 0, this will be a negative value. So inside this z, there are some positives and there are some, half of them are positive, half of them are negative. So when you are calculating the upper and lower limit, one of them will be positive, one of them will be negative. So this minus will become either plus or minus. So a formula for, let us say, 1 minus alpha times 100% confidence interval of mu is what? It is x bar plus or minus a value from z, which we name as z alpha by 2 times sigma over root of n. This is the formula that will be given to you in the formula sheet. Again, I repeat, this small derivation has nothing to do with this course. This is just for your interest, that it comes from that formula of z when we solve that formula of z for mu. What you are supposed to understand is whenever you want to make a confidence interval for mu, this is where you will plug in all the values. And what is this? This Z, this comes from the Z table. Sigma is the population standard deviation. N is the sample size. X bar is the sample mean. So this formula of 1 minus alpha times 100% confidence interval for mu contains 4 things. X bar, which is the sample mean, Z alpha by 2, this is a critical value of Z that comes from the Z table, sigma, which is the population standard deviation, and N, which is the sample size. I'm going to explain how do we get this value of Z alpha by 2 from the Z table. Before that, if you have any question from the remaining 3 components of this confidence interval, you can raise your hands now. Okay, in case there is no question, when you will see a question in exam, the question in exam will give you like something like this. Let us say the question will ask you construct. Let us say 95% confidence interval for mu. Now this 95% is basically 1 minus alpha times 100%. This quantity 95%, that means 1 minus alpha percent. So if 1 minus alpha is 0.95, from this you should be able to deduct that 1 minus alpha is 0.95. This implies alpha is what? 5%.
0.05.
0.05. That's the first thing. The second thing is during this whole course, you will be making two-sided confidence intervals. That is, which will have 2 limits. That mu is between this and this. Sometimes we are also interested in one-sided confidence intervals that we are 95% confident that mu is less than what, but that is not covered in this course. You can make one-sided, but that is not covered in this course. You will always be making two-sided confidence intervals. So when you are making two-sided confidence intervals, you have an interval between one value and one value. So mu can be anywhere here, outside here, outside here. So there is a chance that mu is above 82. There is a chance mu is below 78. So in both cases, you will be making error. So the probability of your error, which is alpha, by the way, in this case, which is alpha, it is distributed on 2 sides. So you should divide it by 2. You should divide it by 2. Always when you are constructing a two-sided confidence interval, and in this course you will always be constructing two-sided. So the third step here is you divide alpha by 2. Again, step number 1, what will be given to you in the question is 1 minus alpha. Number 2, you have to calculate alpha from there. Number 3, divide it by 2. Number 4, to go to the right side, take 1 minus alpha by 2. To go to the right side of Z table, the right side is the positive side. Take 1 minus alpha by 2. That will be 0.975. A quick comment here, even if you don't take 1 minus alpha by 2, the confidence interval will not be wrong. It will still be the same. We just go to the positive side so that a plus or minus is not disturbed. But even if you take alpha by 2, you'll get the same value in negative. Minus will become plus, plus will become minus. So the confidence interval will be same. It will not make a difference. This is just for going to the positive side so that the plus remains plus and minus remains minus. So once you are done finding 1 minus alpha by 2, this is where you have to go. Once you are done finding 1 minus alpha by 2, go to the z table and look for this value inside the table. And the corresponding value of z at the edge is your z alpha by 2. And let us see what is z alpha by 2 if I go into the z table and look for 0.975. So let me go to the z table and look for 0.975. Yes, Nawaf.
1.96.
Yes, I'm going to highlight that. I'm going to try and find it and highlight it. So let me try and find 0.975. 0.975. I was lucky enough to get the exact value. I will not always be lucky. Keep that in mind. So I got 0.975. And this is corresponding to what? This is corresponding to a value of z which is 1.96. This is corresponding to 1.96. So this 1.96 is your critical value. That's the most important thing in a confidence interval, to get the critical value from the z table. So your z alpha by 2 is 1.96. Once you have z alpha by 2 1.96, it's simple. You go to the question. The question will give you sigma. Let us say sigma is 2. The question will give you the sample size. Let us say the sample size is 36. The question will give you x bar either directly or indirectly. Either the question will give you the value of x bar or the question will give you the sample itself. So you have to calculate x bar from the sample. Let us say x bar is 80. And the question asks you to find a 95% confidence interval for mu. So now it's just plug. It's just plug and get the answer. So you plug x bar plus minus z alpha by 2 times sigma over root of n, plug in the values, and you get what? 80 plus minus 1.96 times sigma over square root of 36. That will be what?
$79.
99. 1.96 times 2. 3.92 divided by 6.65. 80 plus minus 0.6533. So it will be 80 minus this thing. 80 minus this thing will be 79.3467. And the upper limit will be x bar plus. That's 80.65. Once this is calculated, you will say we are 95% confident that mu lies between 79.3467 3467 and 80.6533. That completes the solution. Awaf Ali.
So, Doctor, the lesser the confidence, the bigger the interval.
The lesser the confidence, the
bigger the interval.
No.
That.
The more the confidence, the bigger the interval. I'll give you a practical example. If I say I have to be 99%, okay, I'll give you an example. A student, you don't know about that student. Guess his score, final score in STAT 319. You have no information about the student. And I want you to be 99.9999% confident, almost 100% confident. You will tell me what the score of the student is between what and what?
With no information.
With no information and with 100% confidence.
Between 0 and 100.
Between 0 and 100, a very wide and useless interval, right? But what if I tell you that the average, usually the average of STAT 319 is, let us say it's around 64%. So I ask you, give me a 90% or 50% confidence interval for the score of that student. So you'll give me a little bit smaller interval. You'll say maybe between 50 and 90 somehow. So more confidence means you need a wider interval to cover more confidence. And your question is still there. The first question, why I'm using this word confidence, I'll tell you later why I'm not using, and I'm definitely not using the word probability because of the reason. And before that, I'll bring another question here. Okay, let us look at this question. The question says that the past experience has indicated that the breaking strength of yarn used in manufacturing material is normally distributed with sigma equals 2 psi. Let's highlight the important information. Sigma equals 2 psi. A random sample of size 9, that's n. N specimen is tested and the average breaking strength. Now keep in mind this average breaking strength, is this mu or x bar? Mu is also average, x bar is also average. Is this average mu or x bar?
X bar.
It is definitely x bar. Why?
Because he said the sample of 9.
The sentence starts with a random sample. The sentence is about the random sample, and this, the thing I just told you, this will be very useful in next topic. You will be confused whether the given thing is about the sample standard deviation or the population standard deviation. So you have to see if the thing that is given is does it belong to a sentence which starts with a random sample? If it does, that means it's from the sample. So this 98 is sample mean. And then the last important thing is find a 95% confidence interval. So 1 minus alpha is 0.95. So let me write all the important pieces of information. My sigma is 2, my n is 9, my x bar is 98, and my 1 minus alpha is 0.95. Let me change the value of 1 minus alpha so that we can work with another value. Let's say we can construct 90%. So 1 minus alpha is 0.95. Let us change 1 minus alpha to 0.95 for practice. We have already practiced for 0.95. Let us practice for 0.9. The first thing you need is what? You need the value of z. So you got 1 minus alpha from question, that is 0.9. This implies alpha is 0.1, not 0.01, it's 0.1. Alpha by 2 will be 0.05. And 1 minus alpha by 2 will be 0.95. You will go to the table and look for 0.9500, 4 decimal points. Look for 0.9500 and probably you will not find it exactly. When I go to the table, I try to look for 0.9500. I'll not find it exactly, but I'll find two values, one above and one below 0.9500. And here we have the two values. And 0.95 is right in the middle of these two values. That is another ideal situation that you are getting, that 0.95 is exactly in the middle. But if it is not in the middle and close to one of them, you may take the left one or the right one, or you may take the middle. It's up to you. You can take any of these three. So the critical value against 0.95 is 1.64. That's acceptable. 1.65 is also acceptable, but the best thing is to take 1.645, the middle of 1.64 and 1.65. I repeat, in exam, if you take the critical value 1.64, that is acceptable. If you take it 1.65, that is also acceptable. But the best thing to do here is to take it 1.645. So we take the critical value 1.645. From here, we deduct that z alpha by 2 is 1.645. And once you have z alpha by 2, 1.645, you can say 90% confidence interval for mu is x bar, which is 98, plus minus 1.645 times 2 over square root of 9. And that will be 1.645 times 2 over square root of 9. 98 plus minus 1.0967. 96.9033. And 99.0967. So you will say we are 90% confident that mu belongs to 96.9033 and 99.0967. Any question until this point? And now I'm going towards the question that was raised at the start of the class. Can I also write that the probability of mu belonging to this interval 96.9033 and 99.0967 is 0.90. Can I say this? I cannot say this. Let me cross it out. And why I cannot say this, I'm going to explain it now. I cannot interpret the final answer in terms of probability. And let me explain this. Nawaf Ali, what is your major?
Chemical engineering.
Let us say in my class I have students. Some of them are from chemical engineering. And some of them are from other engineerings. And then I have total. Let us say total I have 31. From chemical engineering I have 10, and the remaining 21 are from other engineerings. Go back to chapter 2. If I pick a student randomly, what is the probability that the student will belong to chemical engineering?
10/13.
Probability that the student belongs to CE, this is 10/31. I can talk in terms of probability. But what if I tell you that I picked a student and the student was Nawaf Ali? What is the probability that he will belong to chemical engineering? Can I even talk in terms of chemical engineering? Once the student is picked, and I know that it is Nawaf Ali, and now I know he is from chemical engineering. Now, either Nawaf will belong to chemical engineering or he will not belong to chemical engineering. Now I cannot talk in terms of probability. Once the unit is picked and the things become constant, the concept of probability goes away. Did you get the point with reference to this example? Now I link it with the confidence interval. But with reference to this example, once the student is picked, the probability of that specific student belonging to CE, I cannot talk in terms of probability. Now this specific student will either belong to CE or he will not belong to CE. You cannot talk in terms of probability. Now come to the confidence interval.
Doctor, I don't understand this point. The specific students belong to CE. It is confident.
No, I'm not talking about the confidence here. Forget about the confidence.
Okay.
Talk about this specific example. Before picking the student, before knowing that who is the student, you can talk in terms of probability. Before knowing anything, there is uncertainty. You remember the first lecture was regarding the probability. The first lecture was it is a measure of uncertainty. Whenever there is uncertainty, we talk about probability. So when there is no uncertainty, when the things are certain, that means I picked the student and now I know the student is whether CE or not CE. There is no more uncertainty. So I will not talk in terms of probability anymore. Once the uncertainty is gone, probability is gone. So now Nawaf will either belong to CE or he will not belong to CE. The concept of probability is gone.
But
no concept of probability.
But we still know, we don't know if it is belong to CE or other measures.
No,
right?
we will ask him. We will ask him after asking him and plugging in. After asking him and plugging in, we will know whether he is from CE. After collecting the data from Nawaf, we will know.
Oh yes. Okay.
Okay. Now let's come back to this formula. This formula is for an interval of mu. Mu is a population parameter. Although we don't know mu, but it is a fixed value. It is between -infinity and +infinity, and it is a fixed value. Before you pick the sample, this thing is a random variable. X bar is a random variable. Before picking the sample, X bar is a random variable. That means it's uncertain. You don't know what will be the value of X bar. But once you pick the sample, you plug in the value of X bar, the whole thing, the interval becomes fixed. Once you pick the sample and you plug the value inside, Your final answer is like this one, 96.9033 and 99.0967. Now, once you plug in the values of X bar, the sample is observed. The limits are fixed. Now, either mu will belong to this interval or it will not belong to this interval. You cannot talk in terms of probability. So the alternative word we use here is confidence, not the probability. So we don't use the probability concept. We use an alternative word here, just an alternative word that we are confident that mu will be between this and this. We don't conflict with the concept of probability because the limits are fixed now. 96.9033 and 99.0967, they are fixed now. Now you will say that we are 90% confident that mu will belong to this and this. You will not talk in terms of probability. Whereas about this one, you can talk. The probability that mu belongs to this X bar plus minus Z alpha by 2 times sigma over root of n. This is 1 minus alpha. As long as the value of X bar is not plugged in and the limits are not constant, unit is not observed, you can talk in terms of probability. But once X bar is observed, the limits are fixed. Then you cannot talk in terms of probability. Then you will talk in terms of confidence, not the probability. And I hope you got the answer.
Good now, Doctor. Thank you.
Okay, any question from this topic?
Doctor,
Yes.
could you please summarize the difference between probability and confidence?
Probability is something that that comes in when you have uncertainty, when the things are not observed. Once the things are observed, the concept of probability is no longer there. For example, I can ask you to predict the stock price of, let us say, Aramco for tomorrow. I can talk in terms of probability. That the probability that the stock price of Aramco will increase from today is this, it will decrease, the probability is this. But once we have tomorrow, once we reach tomorrow, I will know the stock price of Aramco. It will either increase or it will decrease. Once I know it has increased, now I will not say that the probability that it will increase on Tuesday is this or it will decrease on Tuesday is this. Now I know it has increased or decreased. Got my point?
Yes, but what do you mean by observed? Like, for example, in the first chapters, we see that we can observe this set. Then how?
We cannot observe which. Come again?
Could you please give us more examples? Because it's not clear.
Which 6?
Like, for example, I have set 1, 2, 3, 4, 4, 5.
Okay.
And what's the probability that I will pick 3?
You have a set of 1, 2, 3, 4, 5, 6. You have a set of 6 numbers.
Yes.
Okay.
So how do I know if it's a probability or a confidence?
If I ask you to pick a number out of these 6 numbers, find the probability that the number is odd. What will be your answer?
One over 3.
1 over 2, not 3.
Yes.
Number
yes.
is odd
One
is 3 over 6. Which is?
1 over 2.
1 over 2. But if I tell you I picked a number and the number was 4. and the number is 4. Now find the probability that 4 is odd. Can you find this probability? Can you even say that the probability that the number 4 is odd? Can you say the same thing about 4?
No.
No, you cannot talk in
even.
terms of probability.
Yeah.
But you can say this about x, where x is either 1, 2, 3, 4, 5, or 6. You can say this about x, but you cannot say this about a specific value of x.
Doctor, we cannot say it's 0.
No. You cannot even talk in terms of probability.
If it is occur, it's no longer probability.
Something that is certain, you don't talk about that. Probability is what? The first lecture. It's the measure of
Certainty.
uncertainty. When there is no uncertainty, there is no probability. So when you have a sample, and when the sample values are denoted by x, x is random, x is uncertain, x can take any value. So you can talk in terms of probability for the random variable x or the random variable x bar. But once the random variable is observed, it takes a specific value. And once it has that specific value, then it's fixed. It's certain. You don't talk in terms of probability.
Then what can I say about 4? Like I'm 100% confident it's not odd, or what?
Here regarding 4, you will not say anything regarding in terms of probability and confidence, because here you are matching this 4 with something unknown. This is something 4. This is something you picked from the sample. 96.9033 and 99.0067. This is something 4. Observed. Constant. Now you are matching this something with another unknown thing. You're matching this something with another unknown thing. That something unknown is a fixed thing. That unknown is not something random. That unknown mu is also a fixed number. So you're matching this one with another fixed number. So the statisticians, they came up with just a different word against the probability, because the word probability was conflicting with the concept of randomness. So they just came up with a different word to explain the same thing. They came up with the word confidence and not the probability. Is it clear or still not clear?
It's clear now. Thank you.
Okay, now that I have used like 10 minutes of the class on this concept will probably not be tested in exam. This was just for your understanding why we use the word confidence. Okay, go to the blackboard. When you go to the blackboard, you should be able to see class participation number 5. It is visible for next 2 minutes. I'm going to write the formula of confidence interval on your screens. The Z table is attached at the top as a PDF. When you open the participation, you'll see the Z table at the top. Those who have not started the participation yet: Ryan, Asad, Turki, Abdullah Al-Jahili. Abdullah and Turki are yet to start the participation. By the way, you have 2 attempts. If you get it wrong, I will open the test again. You can attempt it again.
Doctor,
Yes, Abdulaziz.
how the answer form should be? Is it an interval with brackets?
No. You will see the last line will either ask you for the lower limit or upper limit. So if the question is asking you for the lower limit, it's with minus. If it is asking you for the upper limit, it's with plus. The answer should be a number.
If I'm done, can I leave the professor?
Yes, if you are done and you got full marks, you can leave the session.
Doctor, the answer should be in which form? Interval or what?
Number. It should be a number. Simple number. Read the last few words of the question again. The question will either ask you for the lower confidence limit or upper confidence limit, only one of them.
Dr. Sigma is the population standard deviation, right?
Right.
Doctor,
Yes, Mohammed.
could you please review my answer? I only just get wrong with number I. Instead of write 58, I write 85.
First attempt or second attempt?
Second attempt. You see, just one number is different.
Why is it?
I didn't know with the time. It's just one number. Instead of 58, I write 55. 50,
It's a big mistake.
85. Yes.
That's a big mistake. We'll deduct -5% from your overall course. Check your score now.
Okay, thank you, Doctor.
دكتور.
Yes, Asad.
There is no second attempt.
There is no second attempt?
Yes.
You want to attempt it again?
Start a new attempt.
Check now.
Okay, doctor. Thank you.
Doctor,
Yes, Muhammad Faris.
all my attempts, 2 attempts are finished, but I still didn't get the correct answer.
What do you want me to do?
Can I do third time?
There are 3.
Yeah, okay. The difference it is 0.5.
No, should not be.
Okay.
0.5 is huge.
Thank you, Doctor.
Doctor,
Yes, Qassam Zaki.
I can't have my second attempt.
Because it's closed. It has been more than 12 minutes since I opened it.
Okay, can I have?
You must have finished it long ago. Let me open it again for just 1 minute, okay? Check now.